Welcome to Nautel's webinar on MER instrumentation for the NV and NX series. I'm Chuck Kelly, and my guest today is Brian Walker, a research engineer here at Nautel, and we're going to try to understand all the intricacies of MER, in fact, what it means. Welcome, Brian.
Thanks, Chuck.
Nice to have you with me. So, first off, what is MER? And oh, I should stop for a second. Throughout this thing, if you have questions, feel free to type on the GoToWebinar engine on the right-hand side of your screen and type the questions in. At the end of the webinar, we will be answering all of your questions. And so do type questions in as we come along. First question is, what is MER?
So MER, or Modulation Error Ratio,
Yep.
is a way of measuring whether you're transmitting a good iBox signal or a poor iBox signal.
Okay.
I mean, the closest analog measurement would be the signal-to-noise ratio of your signal.
Okay. So I was thinking along these lines, I was thinking, in the old days, if I put in a new FM transmitter or AM transmitter, when I was all done, I'd do a proof of performance, and I would verify the performance of the station to make sure everything was right. And I had a number of indices. I could look at frequency response or signal-to-noise ratio, as you put it. But for a lot of people, when they've installed their HD radio equipment, they flipped it on and they did a number of things. They checked to make sure that the forward power and the reflected power were normal and nominal. And then they ran outside with the radio and they verified that, in fact, they could hear the HD radio thing, and then a little light popped on and said it was an HD radio. But apart from that, maybe a spectrum analyzer view, if you had a spectrum analyzer around, apart from that, there was no real way of telling whether the signal was good or bad. So MER is the qualitative measure for the signal quality of an HD radio signal.
Exactly.
Okay, so this is what we're talking about here, is how do we solve the problem for people of how can I fix what I can't measure? How can I tell if my station is doing really good or not so good? Why is it that sometimes when I'm driving around with my HD radio in my car, I can listen to a station and it locks in instantly, and other times it takes quite a while to lock in? It's all related to this MER, presumably.
Exactly.
Okay. So let's talk about the iBox signal composition.
Okay. So on the figure you can see here, obviously you've got your analog FM signal in the middle, and then there's two frequency regions of frequency partitions on either side.
Right.
And those are divided up into reference carriers and data carriers.
Okay.
And the difference between them is the reference carriers, they have some very basic information like your station ID and so on. And then the data carriers, they're what's actually carrying your audio and any data programs you might have on there.
Okay.
So for every single one of those carriers, on each iBox symbol, it can take one of four phases. And that's what you can see on the right-hand
here in the constellation view. Yep.
Exactly. So this constellation, it's a way of visually seeing exactly what each of those carriers are doing. And the way that the receiver makes a decision as to whether each bit coming through is a 1 or a 0 is based on the position of those carriers. So ideally, you want those as far away from the decision points as possible.
So in other words, anything which is in this quadrant here is interpreted as that.
Exactly.
Okay. So another way of saying what you're saying, I believe, is the smaller and more well-defined that dot is, the better the signal quality.
Exactly. And ideally, you want it to be as far away from the origin or the axis there as possible.
Okay. So let's talk about seeing what that looks like. So this was a screenshot we took from a transmitter that's in the building here just a few minutes ago. And the one on the left is an FM transmitter that's doing 23.42 dB of MER. And you can see well-defined small circles in the four quadrants.
Yes.
And over here, what we did is we turned up the modulation too high. And now that's causing those the carriers near the center of the signal up here to be less well-defined, and your MER has gone down to 19.29 dB.
Yes. And I mean, on the graph there, you can see that it looks a little fuzzier because you've got, those points have more of a spread to them.
Now, this 19.29 dB, we're saying it's not as good, but in actual fact, it's way better than the standard ubiquity reference.
Right, and I mean the signal that you could expect out of the XGen with their peak reduction would be around 17 to 18 dB in that kind of range. And the only reason we're getting better than that is because we're using our own peak reduction on the exciter.
And that's something that we do as part of what we've implemented in our most current versions of transmitters.
Yes.
Okay, so what is MER? It stands for Modulation Error Ratio. And it's basically the ratio of the error to the good signal, just like signal to noise.
Yes, exactly the same.
Okay, and it has, there's a standard for the FM side, which has been published by Ubiquity, which is called Transmission Signal Quality Metrics for the FM iBox signals. And we've actually implemented that methodology of measurement into our reference tool.
Yes.
Okay. And is there such a thing for AM?
Well, for AM, there was some start on developing a standard, but it hasn't gotten to the point where there's an actual recommendation yet.
Okay. Nonetheless, we have implemented something very similar in Outlook in our transmitter, our AM transmitter.
Yes, and on the FM side, there were some special considerations made because of the peak reduction used on the ubiquity signal. On AM, there's nothing like that, so we implemented basically a textbook version of a modulation error ratio measurement, which there's a standard way of doing it, and that's what we put in.
Okay, very good. So this is talking about what you were just saying, that the people, no, this is talking about how you measure the MER. Can you walk us through this?
Right, so the first step is that you need to be able to get to the point where you've got that constellation view. So what we've done for that is we've got a iBox demodulation block inside of our exciter, which it's measuring the output of the transmitter, and it's going through. And
so it is actually measuring RF.
Yes, it is measuring RF. This is the same sample that we use for our adaptive predistortion as well.
Okay.
So that signal is demodulated. We go through all the steps to bring it all the way back to a constellation view. And the measurement is fairly simple. It's got an ideal point there, which it would consider to be a perfect signal point. And it's measuring the distance on the graph between that and the received signal. And it does that for all of the signal points going through, averages the power in all of them, and there you've got your measurement.
You can't do this with a slide rule.
No.
Okay. So it requires some pretty heavy-duty computation.
Yes.
Okay.
Yeah,
so explain the modified data carrier MER.
So when the standard was being developed, there was a little bit of controversy about using a standard MER measurement off the shelf because the ubiquity peak reduction algorithm does some special things to the carriers in order to try and bring down some of the peaks. And some of the adjustments that it makes to the carriers, it doesn't move them any closer to the decision boundary, so it's not going to actually impact the receiver, but it would have shown up as being a negative thing on the MER measurement.
As a numerical measurement, okay.
So the reference carriers in the signal, they're all measured using a standard MER measurement, which is just measuring the distance between the ideal point and the receive point. The data carriers, the measurement is done in such a way that it only counts as against the carrier if it moves it closer to the decision boundary. So anything that's more likely to result in a bit error will make the MER measurement worse.
Which is fair, because what we're looking for is a method of determining a negative impact on the signal quality. And that's what it's doing. So that's fair.
And I mean, it's kind of a special case because the iBox signal for FM is using QPSK, which means that the receiver only really cares about the phase of each of the data carriers, not so much its amplitude. So if it gets pushed out a little bit, it's okay.
Okay, good. So this is what happens when MER isn't perfect. You get a reduction in the service contour.
Yes.
So as the data carrier MER falls from the level like we saw on our first screen, you get a reduction in the service contour, just in the same way as you would a reduction in FM contour, except that in digital it either works or it doesn't.
Yes. So I mean, if you look at the numbers there, 24 dB is pretty darn near perfect for a QPSK constellation. There's very little impact on any reduction in the service contour.
Okay.
As that number starts to go down, you eventually do start to see some impact. And 14 dB, which is the last number of black there, was chosen to be the limit by the working group in terms of what they consider to be an acceptable MER at the output of the transmitter.
Okay.
And the reason that was chosen is because, as you can see in that figure, it's about a 0.5 dB reduction in the service contour.
Yep. It also gives you about 3 dB headroom to the standard ubiquity MER numbers of 17 or 18 dB.
Exactly.
Okay.
And I mean, if you were to continue that graph on downwards, it's at about 6 dB, 5 dB, somewhere in there. Your receiver is going to start to lose lock completely.
Yeah, regardless of your signal strength.
Exactly.
Okay, and the other benefit of increased MER, or better signal strength, or better signal-to-noise ratio in the digital domain is improved lock time.
Exactly.
It takes less time to lock. And that's, you know, we're focusing a bit on FM here, but on AM, this also all applies pretty much.
Yes.
And the key thing is that AM takes a lot longer to lock than FM, and this has a huge effect on the time to lock for an AM carrier. Improved MER does.
Yes, that's
So,
true.
okay. So let's talk about transmitter nonlinearity and the effect of that on MER.
So we've done some experiments here. The figures you see are from a paper that we presented a couple of years ago at NAB. And for this experiment, we tried running a transmitter using our standard adaptive predistortion and so on.
Right.
And you can see that the MER, that's the green curve there. And the MER was using the standard ubiquity signal, so it was around 17, 18 dB. Pretty, you know, the transmitter was having basically no effect on the received signal.
Right.
Then we tried turning off the adaptive predistortion, and we changed the load. So equivalent to adding icing on the antenna, and that resulted in the red curve.
Okay, so in other words, we had pretty darn good MER measurements with the adaptive pre-correction, and it degraded by, looks like maybe 3 or 4 dB when you turned off the adaptive pre-correction and changed the load. Okay.
And it brought it pretty much right to the limit. It was sitting at about 14 dB for the MER.
Okay. And then this is also talking about the difference between adaptive and fixed pre-correction. And again, the fixed predistortion is in red, and the adaptive is either in green on this side or white on this side.
Yeah. So there's one important point to note here, and that's if you look at the figure on the left where it's showing the two spectrums.
Right.
In order for you to be seeing that much of an impact on your MER, you're probably already failing your spectrum by a large number of dB.
And not being a good neighbor to the station next door.
Exactly.
Right. Gotcha. Okay, and not only that, you're also hurting your own signal quality.
Yes.
Okay. So let's talk about what happens when you increase the modulation index. And that's not just increasing the volume of the L plus R. It also could mean turning on SCAs or RDSs or whatever.
Yeah, and you see more of an effect on the signal the higher the frequency of the modulation. So turning on a 92 kilohertz SCA is going to have more of an impact than turning on RDS would.
Right. Which is only 52.
Yeah.
Right.
So
Okay.
the figure that we're looking at here, this is with this transmitter that was operating in MP3 mode. So that adds more intercarriers, and in MP3 you're going to be far more impacted by the FM modulation because you're adding more IBOC carriers that are close into the analog.
We should probably clarify that when we talk about MP3, we're not talking about what your kids play on their little music player. We're talking about a different mode in HD radio in which there are more carriers utilized that are actually closer to the analog carrier.
Yes.
Okay. All right. So you can see here the MP3 carriers are closest to the carrier, and the MP1 that are doing most of the heavy lifting, if you will, are further away from the analog carrier.
Right. So you can see with no FM modulation, all of the MERs measured are pretty much equal. And this was, again, using the ubiquity signal, so it's around 18 dB that you're seeing all of those MERs measured at.
So when you add FM stereo, the most inner carriers of MP3 actually drop a few dB.
Right, and that's because we were putting on a fairly heavily modulated signal, and it was starting, I mean, it's at 100% modulation quite frequently, so it was starting to have an impact.
Okay. And then again, if you add RDS plus SCA, well, you're going to get even more degradation. Stands to reason.
And then it's adding that last SCA is really what kind of pushes it over the edge.
The higher frequency one.
Right.
Yep.
Because the SCA1 was at 67, adding the 92 kilohertz SCA had quite an impact on
Sure. The modulation index has an effect to frequency, so that makes sense.
Yes.
Okay. So now let's talk about, you can get some of that back if you increase your data carrier injection.
Right.
Which stands to reason.
So the interference from the analog onto the MP3 carriers is effectively constant. So as you bring the carriers up, then you're going to get a better MER measurement.
You're improving your signal to noise by increasing the signal.
Exactly.
Okay.
And the other thing you can do too is if you move some of those SCAs down to lower frequencies, then they'll have less of an impact as well.
Sure. And as you point out here, you could also move an SCA to one of the HD subchannels and get rid of it entirely.
Exactly.
Okay. So now let's talk about what we've implemented.
So the IBOT quality metric, we've implemented it in both NV and NX. And I mean, there's slightly different implementations, but from the user's point of view, they'll look pretty much the same.
Yep, and we'll see that.
Yep.
Okay.
And so this is in the Release 4 software.
Which is shipping now in new transmitters and available to people for free in a staged release, a limited release, and they just need to contact customer service.
Exactly.
Okay. And it is actually the signal that's coming out of the transmitter. It's actually taking a sample at the output port of the transmitter.
Right.
So it's looking at the entire effect of everything.
And for FM, if the transmitter's off, it actually will measure the signal that you would be putting on the air.
Okay.
So if you're trying to adjust your modulation and so on, it can actually tell you whether what you're about to broadcast is good or not.
Okay. And you mentioned forward and reverse path here.
That's what I mean by that.
Okay.
That the forward path is the signal that you're trying to broadcast. The reverse path is what it's measuring from the output of the transmitter.
Gotcha. Okay, so this is my placeholder to remind me that it's time to switch over and attempt to show everything from here. So this is an AM transmitter. This is actually an NX 200 transmitter running at 100 kilowatts.
Yes.
And it's got modulation and it's working live down on our site right now. And this is the signal constellation view. When we maximize that constellation, which may not show up immediately when you are first turning on the transmitter, first going into the AUI. So you've got to make sure you select the signal constellation for one of your windows. And once you do that, you maximize it. And tell me what I'm looking at here.
All right, so on that top part of the view, you'll see there's all of these bar graphs there.
Yep.
And so if you click on any one of those,
Okay.
then that's going to select that group of carriers to be shown in the constellation, and it'll also tell you what the MER is. So the way that we've organized this is that for AM, all of the different carrier partitions are selectable. And you'll see that there's a listing there where it shows you the details on each of the groups, and that'll tell you the frequency range of them and what type of carriers they are. And so you're looking at all of those carriers grouped together on the constellation view.
Okay. Now, for the people that are not familiar with looking at a constellation view, why is it that when I select these different things, they look completely different?
Well, for AM, not all of the carriers have the same number of bits that are being transmitted on them. Right. So the more data bits that you're transmitting, the more of those positions that you need in order to represent them.
Okay.
So the one that you've got selected right now, Chuck, is one of the primary carriers.
Yep.
And it's got 64 possible positions. So every single symbol, there's 6 bits being transmitted on each one.
Gotcha.
Whereas some of those inner carriers, they only had 4 positions.
Or in this case, 2, because that's a reference carrier.
Right, and for AM, those are also used to help the receiver lock, so it's very important that those are clean.
Yeah, and 45 dB, I'd say they're pretty clean.
Yes.
That's great. Okay, so that's anything else we should show on this?
No, I think that covers it.
Okay, so now let's switch over to the FM, and we'll do the same thing. So we've got the signal constellation selected here. We're modulating this transmitter at about almost 100%. We come up here and we raise that up, and we are looking at one of the inner carriers, a data carrier, and we're getting 22 dB MER.
Yeah, so what we're looking at here, this is implemented exactly according to that specification we mentioned earlier in the webinar. And for the data carriers, it's actually going to show you a group of data carriers all together.
Right.
So that's why you'll see that there's a frequency range. So these are the carriers that go from 137 to 140.
Because there's almost 400 carriers we're dealing with, right? Something like that.
Yeah.
So therefore, you couldn't have a line here for every single carrier.
And it doesn't really make sense.
No.
You know, the things that you're looking at here tend to be trends over the spectrum. So right now, they're all looking pretty good.
Yeah. Okay. So, and you can see that there's a tight pattern around here, and it's all fine. Now, let's go ahead and do something really awful. I should mention that we are in a dummy load right now, so neither the Industry Canada or Federal Communications Commission people can come looking at us right now. So I'm going to take it and over-modulate like crazy and do this and change my on-air signal. And you can see my modulation level has gone up substantially here. And it'll take some time, won't it, because we're going to have to resettle all of this stuff to implement that change. But we should begin to see eventually here a dip here in the middle, which are the carriers that are closest to the analog carrier.
So you can see it's relocking right now. And each of those constellation points, those were before, they were very tight, and they're starting to show some spread.
Right.
Yeah, they start almost looking like little clouds.
Yep. I can see that we are now down to an MER of 17.7 dB. It looks a lot less defined. And you can see a dip here, which is kind of one way to tell me that it's the carriers that are closest to my analog that are being affected, and that's a hint that maybe I'm overmodulating.
Yes, and you're also much more likely to see this when you're in the MP3 service mode.
Right.
This transmitter we're looking at right now is in MP1.
Okay. Okay, but you can see the trend obviously here.
Yes.
Regardless. So, anything else we should show them on this part of the screen?
It's pretty much the same as AM as far as that respect.
All right, so let's switch over, and we're almost getting ready for questions. So if people are formulating their questions, that would be great, and we'll get to answering those. So basically, the MER measurement joins the other innovations that Nautel has led the way on. HD Power Boost, our improved PAPR suite, which results in increased HD power and efficiency. HD Reliable Transport, which reduces IBOC bandwidth load on STLs and makes the STLs in HD mode much more reliable. And MER measurement now is a method of providing instrumentation that allows you to qualitatively and quantitatively look at the performance of your HD system as a whole. Okay, and to summarize what we're talking about here, the MER instrumentation summary, it's intuitive, it's easy to use, it's built-in instrumentation. It allows analysis of the digital signal quality. It's supported on both the NX and NV transmitters, and it's shipping now with all of the transmitters. If you had a transmitter that was purchased before Release 4 was introduced, you can contact customer service and you'll be put on the list for the rollout of that software. And it is a free upgrade for Nautel NV and NX customers. Now, you may have to download it and put it on a memory card yourself and things like that, or you can pay a very small amount and get us to send you that. So, let's see here. Let's go take a look at the questions and see if there are questions that we have received. Let me try to raise this up and make it a little bigger so I can see if there are any questions. So is there a different version of Release 4 software for Power Boost versus non-Power Boost transmitters?
And the answer to that is no. With Release 4, we've actually unified the software so that now everybody for NV is all supported by the same release of software.
Okay. Another gentleman is asking why the delay in shipping 4.0 compact discs. They're not actually supplied on compact discs. They're the compact flash cards. And it depends on whether you're talking about FM or AM. AM is moving along a little quicker. We are getting to the point where we're going to be able to allow people to download that directly. What we kind of wanted to do was a soft release where we throw some units into the field, make sure they're all working right, and then throw some more into the field, make sure they're working right. It's a pretty major change in the NV software release. There's a lot that's changed, and we just don't want to. It's just not just the MER. We just didn't want to overload customer service and everything like that. So there's a bit of a delay in that. Chris is asking, how about multipath? And I'm trying to think of what that has. Is there an effect? If you have poor MER, is that compound the effect of multipath in terms of digital reception?
It will. I mean, the two effects are both going to negatively affect your signal.
Right.
You're not going to be able to measure multipath using the MER measurement on the transmitter. Obviously, you need something that was out in the field to be able to tell that.
Yep. Yep. There's a question about, have you thought about doing a modulation monitor? And in effect, we've done that internal to the transmitter in the Nautel series. If you're talking about having a separate unit that could be used for other people's transmitters, yeah, we talk about that from time to time, haven't made a decision. So if you think that's a good idea, let us know. Let's see here. Next question. Does this require the new NV firmware? For firmware? Yes. Yes. In fact, it's included in the NV4 firmware. That's how you get it. Will this operate on VSHD as well as NV? The VSHD firmware version 4 has not, or VS firmware version 4 has not yet been released. It may be a few more months, but right. It should be.
Once VS 4.0 is, then it will be in there as well.
That will be supported. What about the issue where the constellation gets lost and just looks like a random snowball?
On some of the previous versions of NV software, there were a couple of issues where sometimes exactly that would happen. The constellation would lose its lock and it wouldn't be able to follow the signal. Not that there was anything wrong with the on-air signal,
right.
But it was the instrument. And we've made a lot of improvements to it in addition to the changes that we've made to add the MER measurement.
Okay, great. Would an antenna problem, narrow bandwidth load, for instance, cause a reduction in MER indications?
Depends on what it is.
Okay.
It might.
Yep. If the transmitter, you talked about the icing on the antenna, and that causing the load to change, the VSWR to go up. And if we hadn't had adaptive free correction, it could affect it.
Yes, and it's entirely possible it could. The flip side of that is that our transmitters can sometimes operate into fairly bad loads, and the transmitter may not see a problem, but in terms of the signal being received.
Well, that's another question, is particularly when we talk about AM transmitters in directional arrays, is what it is at the output of the transmitter may be different than what it is in the far field.
Exactly.
And the effects of the nulls and things like that.
So sometimes you find that the problems in receiver locking may not just be because of MER, maybe because there's a fairly significant frequency response.
Right.
And you're not going to see that on the MER measurement.
Is there a baseline firmware version to allow the upgrade? My understanding is that that was an issue, and we have made some changes in the software releases to make it so that any version of the system that can support the NV can support NV4. Is that correct?
I believe that is correct, yes.
Okay. Are the webinars available for offline viewing? I missed the release 4 one. Yeah, every one is available. Go to nautel.com/webinars, I believe. That's on a coming slide here. So yes, every webinar we've done since the beginning of time is there, and it's good for a good afternoon of rainy weather or something. You're viewing at your choice. In fact, here's where you can find that. It is /webinars. Some other data points of places to keep up with information. The Nautel Waves newsletter is a great resource. Every couple of months we send out an email newsletter with information. Check out our YouTube page at Nautel Limited, and check out the Nautel store where we can provide parts and other products available. Of course, customer service is available 24/7, 365. We do have the ability of online chats as well. So we've got a number of ways for you to keep in touch. And of course, the Nautel sales department is always ready and excited to come to your assistance, and just contact the regional sales manager in your area or email us at sales@nautel.com. Any final thoughts, Brian? Thank you very much for participating.
No, I mean, I hope this is a useful tool.
A lot of these kinds of tools come from suggestions we get from customers, and then I can certainly empathize with people who have sat there over the years and installed an HD radio system and wondered if it was working properly or not. And now, for the first time, and at no additional cost, we've given you a room full of test equipment to verify that.
Well, exactly. Between this measurement and being able to look at the spectrum.
Yep, very important. So thank you very much. If you missed the beginning of this, you can go back in a day or so and download it and watch it online. Thanks very much. I'm Chuck Kelly for Nautel. See you next time.